1 in every 10 babies around the world is born too early, and in many of those cases, medicine still cannot fully explain why labor started before it should have. But researchers are getting closer, and what they're finding is reshaping everything we thought we knew about the biology of birth. Preterm birth, defined as birth before 37 weeks of pregnancy, is one of the most common and most serious complications in maternal health worldwide. It's a leading cause of newborn illness and death. It affects families across every demographic, every country, every background. And yet, despite decades of research, spontaneous preterm birth remains one of medicine's most persistent puzzles. Today, we're going to look at what science currently understands about why some pregnancies end too early, the known risk factors, the biological mechanisms researchers have identified, and the significant gaps in knowledge that still remain. What preterm means and why it matters. A full-term pregnancy is considered to last between 39 and 40 weeks. Babies born before 37 weeks are classified as preterm. Those born before 28 weeks are considered extremely preterm and face the most significant health challenges. The earlier a baby is born, the less time it has had to complete critical developmental milestones: lung maturation, brain development, immune system development, and the regulation of body temperature. Premature babies often require intensive care. Many go on to thrive, but preterm birth remains a serious medical event with long-term implications that researchers continue to study. Known risk factors. Research has identified a number of factors associated with increased risk of preterm birth, though having a risk factor does not mean preterm birth will occur, and many preterm births happen in pregnancies with no identified risk factors at all. A previous preterm birth is one of the strongest predictors. If a woman has delivered early before, the risk is higher in subsequent pregnancies. Carrying multiple babies, twins, triplets, significantly increases the likelihood of early delivery as the uterus reaches capacity sooner. Infections, particularly infections involving the reproductive tract or urinary system, are associated with preterm labor. Inflammation appears to be a key biological mechanism here. Cervical length is another factor. A shorter cervix, detected by ultrasound, has been associated with higher preterm birth risk. Stress, particularly chronic, severe stress, has been linked to preterm birth in multiple studies, though researchers are still working to understand the exact biological pathways. Other factors include certain chronic health conditions, nutritional status, pregnancy spacing, and genetic predispositions that science is continuing to map. The biology behind early labor. Spontaneous preterm birth doesn't have a single cause. Researchers now understand it as a syndrome, a final common outcome that can be reached through multiple different biological pathways. One major pathway involves infection and inflammation. When bacteria enter the uterine environment, the immune system responds, and those immune responses can inadvertently trigger the same cascade of changes that initiates normal labor. Another pathway involves stress hormones. Chronic stress activates the hypothalamic pituitary adrenal axis, a system that regulates the body's stress response, and this can lead to elevated cortisol levels that may prime the uterus for earlier activity. A third pathway involves structural problems, like a weakened cervix that begins to open too early, or issues with the placenta that disrupt the signals maintaining pregnancy. In many cases, multiple pathways are involved simultaneously, and in some cases, the triggering event happens long before any symptoms of preterm labor appear. What research is still working to understand. Despite significant advances, there is still no reliable way to predict preterm birth in most cases, and no universally effective way to prevent it. Current interventions include progesterone supplementation for some high-risk women, cervical cerclage, a stitch to support a weak cervix, and careful monitoring. But researchers are pursuing deeper solutions. Genomic studies are looking for genetic signatures that predict risk. Microbiome research is exploring how the bacteria in the reproductive tract influence pregnancy stability. Biomarker studies are searching for measurable signals that preterm labor is imminent. What's become increasingly clear is that preterm birth isn't one problem, it's many problems that look alike on the surface but have different origins. Solving it will require solutions as varied as the causes themselves. For any family touched by preterm birth, the experience is often frightening, confusing, and isolating. One of the things science is working hardest to offer is not just a treatment, but an explanation, a reason, a biological story that helps families understand what happened and why. We aren't there yet for every case, but the research is closer than it's ever been. And in medicine, understanding comes before prevention. If you or someone you know has experienced preterm birth, please know the science is working for you. Share this for awareness and follow for more evidence-based pregnancy education.